All right, continuing where we left off in Unit 1 with solving linear equations. Now we're going to be graphing linear equations. And this, keep in mind, this is an Algebra 1 review unit, so probably stuff you've seen before. Linear equations, they can be written in 3 different forms. We're going to go over graphing all 3 of these before you have some practice on your own, and then get started on some homework problems. First being slope-intercept form, second being standard form, and the third being point-slope form. Okay, we're going to quickly review the details of each of these 3 forms, starting with slope-intercept. So this linear equation form is called slope-intercept because it uses our slope, which is our m, and our y-intercept, which is our b. Remember, y-intercept is where the line crosses the y-axis. The slope is a couple different formulas you could use. It's your measures the steepness, it's change in y over change in x. It's rise over run. If you're given point, it's y2 minus y1 over x2 minus x1. Just keep in mind it's the vertical change over horizontal. Okay. 2 other components here, x and y. X represents the inputs of this linear equation, and y would be your outputs. And we'll see a couple real-life examples of linear equations in slope-intercept form when we meet together during our Zoom. Let's continue with standard. Standard form is ax plus by equals c. Just 2 important parts of standard form. A, b, and c need to be whole numbers. So if you have fractions as your coefficients, remember, coefficients is just the number that comes in front of the variable. You can get rid of those fractions, and we'll talk about how when we practice some in just a sec. And then a, that value in front of x needs to be a positive whole number. We can also talk about how to make that a positive whole number when we graph some examples in just a bit. The way you're going to graph using in standard form is you're going to graph using intercepts, x and y intercepts. And it's really easy to use the x and y intercepts because your x-intercept is where y equals 0, and your y-intercept is where x equals 0. And you can see that right here. It's really showing you the same thing. Y-intercept is where x equals 0. X-intercept is where y equals 0. We'll graph a couple examples in standard form on the next page. And then point-slope form. This is called point-slope form because you graph using a point, which is your x1 and your y1. So that's the known point that you have in this equation. And then your slope of m. One thing to keep in mind here is that the minus sign or minus signs in front of x1 and y1 make the coordinates the opposite. Okay. And then a last couple important things to remember for linear equations. A horizontal line, if we were to graph a horizontal line, it would look like this. Horizontal lines have a slope of 0 because once again, you guys can see right here, it's rise over run. Okay, so if we have a horizontal line, there is no rise, so our vertical change would be 0. There is a change left to right. It's some number, it's an infinite number. We can really put anything over there because 0 over any number is just 0. So horizontal line, slope of 0. Vertical line would just be the opposite. For a vertical line, we do have a vertical change, but we don't have a horizontal change. And anytime we're dividing something by 0, this is undefined. Okay. Parallel lines. Parallel lines are lines that do not cross, so something like this. And if you had parallel lines, they would have to have the same slope. M equals, let me just say this is a slope of 2/3. M equals 2/3. So parallel lines, same slope. And then perpendicular lines, slopes that are opposite reciprocals. Remember, perpendicular lines are lines that intersect at 90-degree angles. So two lines that intersect at 90-degree angles. If this was a slope of, say, let's say 2/5, then this slope would need to have the opposite reciprocal. Opposite meaning negative, reciprocal meaning flipped. So -5/2. Okay, let's go graph some of these linear equations in all three forms. So A is in slope-intercept form, B is in standard. We actually don't have any point slope form on here, so maybe we'll do, that's okay. We'll have an example where we graph point slope form in the next section in our notes. Okay, let's go ahead and start these together. For A, when you're graphing in slope-intercept form, you want to start at that y-intercept. That's a point. Keep in mind you need at least, at the minimum, 2 points. 2 points to graph a line, or a linear equation. So we have one at our y-intercept. Then you can just use your slope. A slope of -2/3 means you can go down 2 to the right 3. Or you could go up 2 to left 3. Okay, either way works. You can put the negative with the 2, or you can put the negative with the 3. Just don't put it with both, because that would make your slope positive. And then we can sketch our line here. Great. For B, if you would like, if you're really comfortable using slope-intercept form, you can start solving for y. You can move the 3x over. You get -5y equals -3x minus 15. Divide by -5, and we get y equals +3/5 x plus 3. And you could graph that slope-intercept form. It's the same exact equation. Or I want to quickly show you guys how to graph using or using standard form. This is already in standard form. X and y are on the same side. They're both positive whole numbers for your coefficients. Use your intercepts. So if your y-intercept is where x equals 0, you can cover this up, and you can quickly see that when you solve for y, you would get your y-intercept at, I'll divide both sides by -5, you get a y-intercept at +3. And then if we were to cover up our y, because our x-intercept is where y equals 0, we get, and then you divide both sides by 3, we get an x-intercept at -5. And we can go ahead and graph those 2 points. You only need 2 points to graph your line. So our y-intercept would be up here at 3, our x-intercept at -5. And you have your line. Hopefully you can see y-intercept, same on both equations, it checks out. Check your slope, it's up 3 to the right 5, or down 3 to the left 5, and that also checks out. Great. For C, you have the equation y equals. If your equation is y equals, that means you do not have an x-intercept. There is no x value. So if your equation is y equals -3, you have a point at -3, and if there's no x-intercepts, y equals is going to be a horizontal line through that -3. Which means for D, when you only have an x variable and you do not have a y variable for your equation, and you isolate that variable, get it by itself, that means you only have an x-intercept, you don't have a y-intercept, so this would be a vertical line going through +4. Okay. Plenty of practice graphing linear equations for homework. Your homework problems are going to be numbers 1 through 9, all of them. And we will check those, or you will check them on your own when the solutions are posted. If you have any questions, I can answer them during the Zoom call.